Hello, this is Ayan, a PhD student at SketchX, University of Surrey. In this paper, we introduce a new and improved paradigm for neural sketch generation. To this end, we introduce a neural model for learning representation of parametric curves. Traditional sketch generators like SketchRNN or handwriting generation models use explicit waypoints for trajectory representation. They are relatively longer, have temporal correlation, they are fixed resolution, and of course, of bad quality. You can see an example on the right-hand side. On the other hand, vectorized sketch generators like Spiral or SVG font generators use parametric curve specification, that is control points of Bezier curves or splines. They are relatively shorter, they are inherently of arbitrary resolution, and of course, of high quality. The circular stroke has 25 points on its naive representation, whereas 10 control points on the Bezier representation. We introduced Bezier Encoder, an inverse graphics-based encoder for Bezier representation. It converts the traditional waypoints to Bezier curves. This model is learnable, high quality, and faster than standard fitting Bayes method. We feed the waypoints as input to an RNN to produce the Bezier representation. However, we don't have enough information to train the model. What we do next is predict the t-values corresponding to each waypoints, which we then use for reconstruction. Given the control points, these t-values have one-to-one correspondence. We make use of the Bezier curve model to create the reconstructions. Please note that here we have a parametric encoder and a non-parametric decoder, which makes this model an inverse graphics-based approach. For training the model, we simply minimize the reconstruction loss for all waypoints. We also extend this formulation to create an ensemble loss that can produce different Bezier representation for a pre-specified set of degrees. We also add a regularizer for learning better representations. We essentially add a constraint to keep consecutive control points closer to each other. Following are some traditional stroke and sketch representation and their Bezier encodings. Please note that only this part is used for inference and everything else is thrown away. The generative model has two modes. First one, the control point mode. Here, an RNN predicts difference vector of successive control points and keeps doing it autoregressively. It also predicts a stroke end and a sketch end bit, just like SketchRNN. This way, the average length of generated sketches went down by 33%. Another mode, namely the stroke mode, predicts the next stroke of a sketch and keeps doing it autoregressively, just like the control point mode. For obvious reason, it used a fixed degree Bezier representation. The number of time steps of the RNN becomes the number of strokes in a sketch. Here we show some qualitative results. We show conditional and unconditional generation samples for both the modes. That's all for this work. In future, we will investigate extending this formulation to more complex parametric curves. Also, creating an encoder which predicts parametric curves from raster images is also a prominent direction. Thank you.